Okay, so in the last video, it was quite a quick go through of the sine and cosine rule. I don't want to spend too long on that particular aspect of it because I'm just trying to introduce the equations and roughly how they work. If you want to practice that over and over, that's absolutely fine. I'm more interested now in just getting on to some of the trickier questions that you can get. So the questions that are going to make you think, oh, wait a minute, so there's like curveball in the question. So for this one, let's just check. Let's read the question. In the triangle XYZ, so it's my triangle XYZ, x to z is 10. Okay, so they've told us that in the diagram. Don't need that. Y to z is 8. They've shown me that over here. And cos of z is 1/8. So this angle in here, let's if we call that then, cos of that angle, so cos of z is equal to 1/8. We don't know the angle, but I know that if I do cos of that angle, it would give me 1/8. Okay. Calculate the length xy, and I would just call that, well, it's opposite z, so we call it z, opposite z. So what am I going to use? Am I going to use sine rule or cosine rule? Well, I have 1, 2, 3 sides, so it's going to be the cosine rule. I'll just take that off just out of easiness. So the cosine rule is going to be a squared is equal to b squared plus c squared minus 2bc plus a, which again is given to you, that's fine. So in this case, it's going to be z squared, because I'm trying to find this length here, is equal to 10 squared plus 8 squared, but it doesn't matter which is which, does it? 2 times 10 times 8. I've called them B and C. Doesn't matter. The point is, I'm working out this length, then I have to use that angle opposite. So it's times cos A. Okay. The B and C doesn't matter. The point is finding this length means you're using this angle in here. Now, actually, this is quite straightforward, isn't it? Because there's not really any other options. We're basically just substituting in the only data we know. I'm just trying to make you realize that if we knew this angle and this angle, we would have to work out this angle. You have to make sure that the A's are opposite from each other. So that length there, A, Z, is this angle here, one opposite. So cos A, now usually they would give you the angle and you would say cos of 60 degrees or whatever. But this has actually done it for us. It said, well, wait a minute, cos of that angle is 1/8. All I have to do is put in 1/8, not cos of an eighth, just 1/8. This whole term here, cos alpha, cos A, is the same as 1/8, isn't it? 1/8. So let's go into the next bit. So it's z squared, or call it if you want x squared or whatever. That's going to be 100 plus 64. Take away, now I put this in a little bracket, this bit. Now let's think about this. 2 times 10 times 8 times an eighth. Well, let's make our life easy for ourselves. Instead of doing 2 times 10 for 20 and times them by 8, dividing by 8, what if I was to do 8 times an eighth? That's just going to give me 1, isn't it? 8 eighths are 1. So they just cancel out. So you're left with 2 times 10, which is 20. So z squared is equal to 164 take away 20. So that's 144. And this is the bit people kind of leave at. They think, right, I finished it. If you don't keep writing this down, you will make the mistake and just finish off at 144. But z is then the square root of 144 is equal to 12. And the units for this are centimetres. So, make sure you keep writing that all the way down, just to remind you at the end to do the square root, and watch out for that. So a lot of people would put in cos of an eighth and say, well, I can't do that, I need a calculator. So in the non-calculator paper, they sometimes give you what that equals. So that's one way they can, make it a little bit trickier. The other way they can make it trickier is to throw in some angle rules. So let's have a read of this question. Okay, so I know that, that's in the diagram. I would say you should feel free, I hope you are pausing it as when you get to the question and see what you think, and then listen to me prattle on. We've got that in there, we've got that. So everything is in the diagram. This is just unnecessary words. Just trying to put proper mathematical terminology in there, but in reality, you don't need it. I can see all that. Calculate the length of DC. That's going to be that. Calculate the length of DC. DC, David Coulthard, favourite Scottish Formula 1 driver now. How are we going to solve this? Okay, well, there's my triangle. If I want to find this length, I've got one length, I've got another length. If I want to use the cosine rule, I'd need to know this length in here, which I don't. So right away, I'm actually thinking, okay, well, it's going to be sine rule. But the problem is if it's sine rule, I need to know this angle as well. I've got this pair, I'd need to know that angle. How can I get that? Angles in a straight line add up to 180. So I know that that is going to be 105, because that whole thing adds up to 180, which means I've got a nice pair here as well. So write my equation out. I'm finding a length, so I'm going to do the A over sine A version of the equation with the length on top, so it was a bit easier. And I'll substitute in. So that's my x over sine of 105 equals 20 over sine of 37. To move the sine 105, I need to times both sides by sine 105. It's going to be sine 105 times 20 divided by sine of 37, which will come out as 32.1 centimeters. So not wildly different from the first sine rule question we had up here. If anything, this is a little bit more tiny bit more tricky because you've got to move the sine over at the end. But once you get past this, that you've got your angle in the triangle, you're okay. I think. Yeah, if you were struggling with that, if you knew to use the sine rule and you were thinking, well, how do I work that out? Just make something up. If you're really not sure, demonstrate you can do the sine rule, you can rearrange, you can solve. You would just lose 1 mark for not knowing how to work this out. So don't not go on. If you be confident and say, well, I know it's the sine rule, it's definitely the sine rule because it can't be the cosine rule. So I'm gonna go and do that. That would get you something. Okay, so for the 3 marks, better to get 2 and lose 1 than to say no, I'm totally stuck. So yeah, demonstrate what you know. And very last question. Well, there's touchy. There's there's 2 last ones. I think I'll just do a separate video for these because this is the hardest way they get. And I'm not even sure if this is still in after code. I'm not sure if they've taken bearings out. But this is the way to make it really hard. So I'll go through these 2 questions in a separate video, and that's everything you really need to know about sine and cosine rule.